EM wave. What is the EM wave? Why it is called as electromagnetic waves? And what is the informed plane wave? And why it is also called as the transverse wave? So those things we are going to see the basic concept about this EM wave. So I welcome all of you here. So now first what we'll see here, we have taken example that wave is propagating along the z direction. So when wave is propagating along the z direction, so here electric field and magnetic field components have direction perpendicular to the direction of propagation. That means if wave is propagating here along the z direction, then electric field components and magnetic field components will propagate either x direction or y direction. If electric field is going to propagate along the x direction, then magnetic field will propagate along the y direction or vice versa. Okay, both will not be in the same direction and both will not be in the direction of the wave propagation. So here you also can see that electric field component, magnetic field component, and wave propagation all are perpendicular of each other. So due to that, it is also called as orthogonal. So finally, if the wave in which electric field and magnetic field lie in a plane and have same magnitude everywhere in that plane for a particular instant of time, then it is called as the informed plane wave. And here it is perpendicular to each other, so that is having orthogonality. So how you will define the informed plane wave? So that is the when electric field and magnetic field both are in the same plane and they have magnitude same everywhere, okay, at particular fixed instant of time. Then it will be called as the informed, since magnitude is same for the particular instant of time. So here we have a space domain representation. Later we'll see that in time varying field, how it is going to change. So whenever, if there is the time varying nature, then only that wave is going to propagate. So at instant of time, they have same nature. In another instant of time, the nature is going to change. So here what we are going to observe that in case of a space variation, that electric field and magnetic field components are zero, okay, in constant plane. So here constant plane is what? For the particular value of the z, we are going to get the constant plane. So due to that, we have dou by dou x equal to 0 and dou by dou y, this is also equal to 0. And z component of electric field as well as z component of magnetic field, both are going to be equal to 0. So next we have velocity of propagation of the wave in free space. So generally, later we'll see that in the derivation part, the velocity of the wave is given as 1 by root under mu and epsilon. So mu is the permeability, epsilon is the permittivity. So in case of free space, what will happen? In case of free space, and you know that already here, what is the mu? Mu is the mu naught into mu r. Epsilon is epsilon naught into epsilon r. So in case of free space, what will have? Mu r and mu r and epsilon r value is going to be equal to 0. So finally mu will become mu naught, epsilon will become epsilon naught. So finally if you substitute the value here, so mu naught value, what is the mu naught value? We have 4 pi into 10 to power minus 7 and epsilon naught value is what? 10 to power minus 9 divided by 36 pi. Okay, so these are the 1, upon a square root of this. So substituting this value, you'll find here that this is equal to the 3 into 10 to power 8. So that is the velocity of the light in the Fourier space. That is also called as the speed of light. So this value, how much we are going to get? 3 into 10 to power 8 meter per second. So this is what going to be equal to c, that is the velocity of light in the Fourier space. So whatever frequency is going to be there, the electromagnetic waves will travel in the Fourier space with the velocity of light. And plane, why it is called as the transverse wave, okay, and why it is called as the transverse electromagnetic wave, okay, transverse wave, or another what we call transverse electromagnetic wave. Why it is called like this, that we are going to see now. So in this part, what you will observe that already we have discussed that electric field and magnetic field both are perpendicular to each other. That is called as the transverse. And it is the perpendicular to the direction of propagation also. So it is called as the transverse electromagnetic wave. They are perpendicular to the direction of wave propagation as well as that perpendicular among them itself also. So it is called as the transverse electromagnetic wave. And already we have seen in this situation that component of E and H in the Z direction is 0, and dou by dou X and dou by dou Y, that component is also going to be 0. So it shows that it has uniform plane wave and it is transverse in the nature. Now we have different types of the wave in different mediums. Okay, so that discussion we'll do later one by one, and here we can summarize those results that will be useful for us to understanding the nature of this wave later. Okay, when we'll have discussion about each wave separately. So finally here, what we are seeing that, so what is the wave? Why it is called as the wave, or simply if you have mechanical wave also, or we have electromagnetic wave also. So what is the wave actually? So it means of transporting energy or information from one place to another place is called as the wave. Like we are making the communication with help of mobile, or even how we are going to talk to others in the nature also, so that how sound wave is going to travel. So that is also wave. But electromagnetic waves have energy. Okay, it can utilize in the different format, but mechanical wave doesn't have such type of the energy that can be utilized. Like suppose, for example, if you are taking one pole here, okay, in this pole you have tied some rope, and that rope you are shaking. So that is also going to generate the mechanical waves. Whether this wave we are able to utilize for any purpose, whether it has some sufficient energy that can be utilized, no. So electromagnetic wave have energy, and in general, what is the wave? Transporting of energy or information. So how wave is going to propagate? If it is going to propagate through the free space, that means conductivity is 0 and epsilon is equal to epsilon naught, mu equal to mu naught. Whereas in case of lossless dielectric, so lossless dielectric also we call as the perfect dielectric. Okay, lossless dielectric, what we can call another name, perfect dielectric. So in case of lossless dielectric, conductivity is 0. Mu is going to become mu naught into mu r. Epsilon is going to become epsilon naught into epsilon r. And here conductivity is much smaller than omega epsilon. So later we'll have value of the alpha, beta, where we have attenuation constant, propagation constant, and phase constant. So there we'll see the importance why we are going to compare sigma with omega epsilon. And again, we have lossy dielectrics. So this lossy dielectrics, here conductivity is not equal to 0. And remaining situation here, epsilon is equal to epsilon naught into epsilon r, mu equal to mu naught into mu r. Whereas in case of good conductors, okay, its conductivity is very high. So that is almost infinity, and epsilon is epsilon naught, mu is mu naught into mu r. And here conductivity is very high. So here we have sigma is much greater than omega epsilon. So these are the discussion, okay, about what is the informed plane wave, why it is called as transverse electromagnetic wave, and why its nature is the transverse. And we have seen different types of the medium in which wave is going to propagate. Okay, thank you very much. Like, subscribe the channels, and write the comments. Whatever your question is there, please put it here. Thank you.